In this lab report, I will describe and discuss how I observed and analysed the motion of an object moving at roughly constant velocity. In this lab, I tracked the motion of a ball of mass 80 grams over time 1.335 seconds. This is an upside down image of the video I shot. I really apologise for the poor image quality. The computational model used was based on Newton's second law for a case where the total pushes and pulls on the system equaled 0. Newton's second law says that final velocity, Vf, V final, equals initial velocity, V initial, plus F net, the sum of all pushes and pulls acting on a system, divided by the mass of the system times delta t being a small change in time. So the previous algebraic expression of Newton's second law was iteratively applied together with our knowledge of how to predict a new position. On this slide, r is the displacement vector, v the velocity vector. So I applied these physics principles and used the VIDLE program to create a computer model of the ball in motion. I used the motion software program Tracker to create a plot of the motion I observed. Here is the eventual plot of the experimental position data versus the computer model data. My experimental data compared with the model data didn't match very well. My experimental data seems to be saying that my ball was slowing down slightly and also travelling slower than predicted. Now, some key assumptions of this experiment were that we were looking at straight line motion in one dimension. In fact, my ball drifted in the positive y-axis direction, as can be seen from the data in Tracker. Also, we ignore the effects of friction. I believe this is implied by our assumption that F net equals 0. So I'm wondering if these assumptions might account for the slightly poor match between my experimental data and the computer model data. Also, I may have started the analysis of frames too early. Thinking about the case where we flip the axes so that the vertical axis displays time and the horizontal axis displays position, if I'd done this, because the motion I observed ran from left to right, the orientation of my graphs would still be from left to right in a northeasterly direction. I have done a rough plot using only key data points by hand of the change of the flipping of the axes, and that showed that the gap between my experimental position, my model. I have done a rough sketch with flipped axes using only key data points, and what I found was that the gap between my model curve and my experimental curve was even wider than is currently shown here. In closing, I'd just like to comment on my kinky experimental position graph line. This was due to my data appearing to cluster at certain time points. So for example, here I have the same position reading for different time points, and again down here I have a cluster of very similar readings, 0.61, 0.66, 0.661, 0.66, across 4 different time points. So I'm wondering if this was due to my poor recording equipment. Thanks for listening.